is the space around a mass in which another mass experiences the gravitational force. The strength or intensity of gravitational field is, suppose this is the mass m, and at this point P, due to this mass m, you want to find the gravitational intensity. So that gravitational intensity will be the gravitational force on a mass here, okay, on this test mass divided by the test mass. So gravitational intensity E is equal to gravitational force divided by mass. Gravitational force between these two masses, G into m1 m2 by r square. Okay, when you will divide, you will get E is equal to gm by r square. E is equal to gm by r square. So you can say if you have a mass m, and due to this mass m, there is a point P which is at a distance of capital R, which is a distance of capital R. Due to this mass m at point P, the gravitational intensity E is given by G into mass m divided by R square. Okay, so this is the magnitude of the gravitational intensity. Now for the direction of the gravitational intensity, from this point P, the direction of the gravitational intensity will be in this direction. Okay, so we were discussing this question. There are two masses m and 4m, 9 centimeter apart. So we have to find the point on the line joining the two masses where field is zero. What is the meaning of the field here? Because here are masses, so the field will be due to masses, that is gravitational field. The field due to masses is gravitational field. So I told you that on the left of this mass, the gravitational field cannot be zero. I told you that on the right of this 3m mass, the gravitational field cannot be zero. In between these two masses, the gravitational field can be zero. Hello, Divyangi.
Good evening, sir.
Good evening. So we were discussing the last question of the last class. Okay. So I told you that here the gravitational field cannot be zero. Here the gravitational field can be zero because direction of two fields due to masses opposite. Here cannot be zero. Here cannot be zero. So they are asking point on the line joining the two masses where field is zero. Okay, where field is zero. Okay, so suppose this is the point P at which this is the point P at which the gravitational field due to both the masses is zero. The gravitational field due to both the masses is zero at this point P. Okay, so due to this mass m, due to this mass m, at this point P, what is the direction of the gravitational field? In this direction. And due to this mass, at this point P, the direction of the gravitational field will be in this direction. And this whole distance is 9 centimeter. This whole distance is 9 centimeter. So we have to locate this point. We have to locate this point. So suppose from this mass, this point is at a distance of x. This is not n, this is x. I write x like this, so this is x. So if this distance is x, So this distance will become 9 minus x. This distance will become 9 minus x. Now find the magnitude of E1 and E2. So for the gravitational intensity at any point, the formula is gm divided by r square. Now due to mass m1, the E1 will be g, you will take this mass m divided by the distance. Now distance between this mass and point P is x, so it is x square. Now E2, g into 3m divided by the distance square. So the distance between this mass and point P is 9 minus x. So 9 minus x square. And at point P, we assume that the gravitational field is 0. Means if the gravitational field is 0, means this vector and this vector should be equal and opposite. Should be equal and opposite. Or you can say the net value of gravitational field at point P is equal to 0. And what is the net value? Here are two vectors. I told you if there are two vectors, that is A vector and B vector. They are acting at 180-degree angle. So at point P, at this point P, if you want to find the net resultant of this vector, so it will be basically either B minus A or A minus B. So it will be A minus B. Now here, two vectors, this is a vector quantity, this is also a vector quantity. So you can write E1 minus E2 or E2 minus E1. E2 minus E1 is equal to 0. Or E1 minus E2 is equal to 0. So it will become E1 is equal to E2. So what is E1? Gm by x square. And E2 is 3gm by 9 minus x square. Now this m and m will be cancelled out. This g and g will be cancelled out. This mass is take this mass as 4. Okay. 4m. So here it will be 4. So we have now 1 by x square. And this is equal to 4 by 9 minus x square. 4 by 9 minus x whole square. Take the under root on both sides. So you will get 1 upon x. And here you will get 2 divided by 9 minus x. Now if I write under root of 4, so under root of 4 is basically plus minus 2. So we have to consider one more case. Here it will be 1 by x, that is equal to minus 2 divided by 9 minus x. So we have to find the value of x from this and this. Okay. Now first we will solve this. So cross multiplication, it will become 9 minus x is equal to 2x. So it will become 3x is equal to 9 and x is equal to 3 centimeter. X is equal to 3 centimeter. Means from this mass, this distance will be 3 centimeter. Okay. This x is 3 centimeter. What is the reference? Means from where you have taken the distance. You have taken the distance from this mass m. So you will consider this as origin. So in this direction, the distance is coming out to be positive. So basically, this point P is at a distance of 3 centimeter from this mass M, where the gravitational intensity is 0. Now, when we will solve this, so it will become 9 minus x is equal to minus 2x. So it will become 9 is equal to minus 2x plus x is equal to minus x. So x you will get minus 9 centimeter. So minus 9 centimeter means from this point there the value is 9 centimeter. So suppose here is the point which is at a distance of 9 centimeter, and okay, and here according to this equation, here the gravitational intensity is 0 on the left of mass m. According to this equation, the gravitational field intensity is 0 here. But we already know that here the gravitational intensity cannot be 0, means we have to reject this value. So our answer will be x is equal to 3 centimeter from mass m, the gravitational intensity will be 0. Okay, the gravitational intensity will be 0 at a distance of 3 centimeter from mass m. With respect to mass 4m, this distance will be 9, and what is the value of x? 9 minus 3, 6. So from mass 4m, the gravitational intensity will be 0 at a distance of 6 centimeter. So they can ask you from this mass m or from this mass m. Now write down this first, then we will discuss the variation of acceleration due to gravity, and we will discuss also what is the acceleration due to gravity, that is small g. This is not a mass 3m, this is a mass 4m. Scroll down. Okay. Hiba, scroll down.
Yes, sir.
Here E is the strength or intensity of gravitational intensity or strength of gravitational field. Hiba, completed.
So what's that?
Okay.
Done, sir.
Okay. written. Okay. Suppose if you are not getting anything, okay, you can ask at that time, okay. Because in physics, uh, there are many doubts for the students because mathematics is involved here. Try to improve your basic maths. Now what is basic maths? Basic maths means basic calculation. You should know basic calculation. Now what is basic calculation? You should know how to solve under root, how to solve quadratic equation, how to solve algebraic expressions, and most importantly, calculus. You should know basic calculus. In basic calculus we have basic integration and basic differentiation. If you have math, then there is no problem, but if you do not have math, then there may be the problem. Okay. uh, Done. Hiba.
Also.
Now we will discuss acceleration due to gravity. Acceleration due to gravity, you also know g. We take this value as 9.8 or sometimes 10 meter per second square. Acceleration due to gravity. So first we will derive the expression for the acceleration due to gravity. What is that? Okay. What is this? This is the earth. This is earth. So basically earth is not a perfect sphere. Earth is not a perfect sphere, but for the calculation purposes, we consider earth as a sphere. So this is the earth. And where we are living? On the surface of the earth, on the surface of the sphere. We are living here, here. Okay. Suppose ME is the mass of the earth, RE is the radius of the earth, and here is a person. This is the surface of the earth. Right now we are at the surface of the earth. Okay. So now I am giving one example. Suppose in movies we have seen Iron Man and we have seen Superman. So they fly. So when they are flying, so they are somewhere here or somewhere here, not on the surface. Okay. When they are flying is they are not on the surface, they are above the surface. So this person is here, suppose, and this person is having a mass m, and this is the center of the earth, and the distance between, and one more thing, this earth as compared to this person is very large. So the distance between the center of the earth and this person is small r. Okay. On this person, there will be a force mg. There will be a force mg. On this person, a force will be acted that is equal to mg toward the center of the earth. That will be the weight of the person. Okay. So you can write here, earth will attract with force that is equal to mg, and this mg is what? Weight of the person. M is the mass of the person, g is the acceleration due to gravity. So basically on this person there is a gravitational there is a weight, there is a force with which the earth will attract, that is mg. Now if we apply the law of gravitation between the earth and the person, law of gravitation, so if we apply the law of gravitation, then with the law of gravitation, what we will get? Force between the earth and the person, or you can say we can also get with what force, the earth will attract the person, that is the gravitational force. So that force is given by F is equal to g into m1. M1, this is m1, take m1 as me, mass of earth, m2 mass of the person, divided by what is the distance between the earth, between the center of the earth and the person, that is r square. And one thing you have to remember, basically this weight and this force will be equal. This gravitational force will be equal to this weight. So you can write gm1. So you can write g into mass of earth into m divided by r square, and this is equal to mg. Now this m and m will be cancelled out. The expression of g now you will have g is equal to g into me divided by r square. So this is the value of acceleration due to gravity. Gm by r square is the value of acceleration due to gravity at this position where this person is available right now. So remember this formula. This is valid for earth. Okay, this formula is valid for earth. Now you can see this is our earth and g is constant, mass of the earth is constant, but this distance can change, this r can change. Suppose this person is here, now I have changed the position of this person, so this r will increase. If this r will increase, then acceleration due to gravity will decrease. So the value of g can change also. Then why we take value of g as 9.8? We take the value of 9.8 on the surface of the earth. On the surface of the earth, we take the value of 9.8. Now, at surface of earth, so at surface of earth, this will be the surface of earth, this point, or you can say this point will be the surface of the earth. So what is the value of r at the surface of the earth? Means here or here, r will become re. This r will become re. So r will become radius of the earth. So you can find the acceleration due to gravity, g into mass of the earth divided by re square. Put all the values. Put the value of g, put the value of mass of the earth, put the value of radius of the earth. So the value of g is 6.67 into 10 to the power minus 11 Newton meter square per kg square. The mass of the earth is approximately equal to, because exact mass of earth we cannot get. 6 into 10 to the power 24 kg, and radius of the earth is approximately equal to 6400 kilometer. 6400 kilometer. So when you will put all the values in this equation, you will get a value of g approximately equal to 9.8 meter per second square. So basically this 9.8 is value is on the surface of the earth. When you will go up from the surface, the value of g will decrease. Okay, write down. This will be earth will attract. Scroll down.
Yes, sir.
Done. Okay. Instead of this Earth, suppose there is any other planet. This is any other planet, and this is also spherical in shape. And radius of this planet is r, and mass of this planet is m. So for this planet, the acceleration means the value of the g will be g into m divided by r square, and r is the distance from the center. Suppose here you want to find the value of g due to the gravitational force of this planet at this point P. So this formula will remain same. G, mass of this planet, R is the radius of this planet. Now this is the question. This is the Earth. Mass of the Earth is given. Okay. Radius of the Earth, and this is a person on the surface of the Earth, and this person is having a weight of 20 Newton. This person is having a weight of 20 Newton on the surface of the Earth. Now somehow this person moved to the planet X. Moved to the planet X. Now on the surface of the planet X, we have to find the weight of this person, given that mass of this planet is half of the mass of the Earth, radius of this planet is half of the radius of the Earth. Okay, so what is weight? Weight is mass of the person. If you want to find weight here, so what you will do? You will take mass of this person multiplied by the acceleration due to gravity here. Mass of the person, acceleration due to gravity here. So m into g. Okay, and this is given as 20. 20 is equal to mg. Now for this planet, suppose w dash is the weight, means we have to find this w dash. W dash is the weight of this person here, and this will be equal to mass of the person, because mass will never change. Mass is the quantity of matter present, and that will never change no matter on which planet you are going. Mass m, but the value of acceleration due to gravity will change, so that will become, suppose, g dash. Okay, so this will be 20, this will be m, And what is the value of G in case of Earth? G into mass of the Earth divided by radius of Earth square. This is W dash. This is equal to M. What you will write for G dash? Mass of this planet. G into mass of this planet. What is the mass of this planet? ME by 2. Mass of the planet into radius of the planet square. Okay. First you will write this, then put the value. W dash is equal to M, and this is G. Mass of the planet is half of the mass of the Earth. Okay. And radius of the planet is half of the radius of the Earth. Radius of the Earth divided by 2 and square of this. So when you will solve it, you will get this will be this is 2 and RE square by 4. So you will get 2 into G into ME, and here you will get RE square. So this is W dash. Now divide W dash with W. So W dash, consider this as equation 1 and consider this as equation number 2. So divide the equation number 2nd by equation number 1st. So it will be W dash by 20. So what is the value of W dash? 2 into small m into G into ME divided by RE square divided by this value GM. Okay, wait. So it will become G into M into ME divided by RE square. This is cancel out, and this is gone with this. This is cancel out, and this ME will cancel out. So what will we have? W dash by 20 is equal to 2. So this will be the weight of the person on the surface of the planet X. Write down. Okay. Completed, Hiba?
Done, sir.
Okay. Sorry. Okay. So now we will discuss how the gravitational acceleration due to gravity will change with height, with the shape of the earth, with the depth. So variation in G above the surface of the earth. So basically in this topic we will discuss how the gravitational means acceleration due to gravity will change with height and with depth, with shape and with rotation of the earth. So first case is this variation in G as we go above the earth surface. So same example, mass of the earth, radius of the earth, and this is the earth, and we are considering earth as a perfect sphere, and this is the center of the earth, and this is a person, and this person now is at a height h above the surface of the earth. From this surface, this person is at a height of h. Okay, so on this person, the earth will apply a force of mg. On this person, a force mg is acting toward the center of the earth, mass of the person, and the value of g here. Suppose g dash is the acceleration due to gravity at this position. Okay. Now this is the weight, means with this force the earth is attracting. Now if we apply the law of gravitation, so the force will be m1 into m2 divided by this r square. So it will be mass of the earth into m divided by the r square. Now the value of this total distance is r. Okay, and this distance is radius of the earth. So this total distance is r. So r can be written as h plus re. So this force F can be written as me into m into g. Here g will also there, and it will be h plus means re plus h. And this force will be equal to mg, m into g dash. Okay, this force now this time will be equal to mg dash. Now from here m and m will be cancelled out. The value of g dash, you will have g into mass of the earth divided by re plus h square. Re plus h whole square. Now we will compare this g dash with g. What is g? G is this value, g into me into re square. G is the acceleration due to gravity on the surface of the earth. So this is G. Okay, we will consider G, this value G into ME into RE square. So now we will compare both the values. Okay, now from this equation, this is the acceleration due to gravity on the surface and this is the acceleration due to gravity at this location. We will compare. So from this equation we can find the value of G into ME, and that will be equal to G into RE square. So now put this value of G into ME in this equation. So G dash can be written as, instead of this G into ME, we will put G into RE square divided by RE plus H and square of this. Now I can write this expression like this: G divided by RE plus H and divided by RE square. So it can be written like this: G divided by RE plus H divided by RE, and this is the whole square. So it can be written as G. Now you can write this RE by RE plus H by RE. RE by RE is 1 plus H divided by RE and square of this. So the expression for G dash as compared to the acceleration due to gravity on the surface of the earth is G dash is equal to G 1 plus H divided by RE and whole square. Note down rest of the things. We will continue this topic and rest of the things we will discuss in the next class.